Good afternoon. In the last class, we have discussed about the pressure measurement and the basic properties of the fluid. Let us continue the same subject with the topic hydrostatics. The hydrostatic means when the fluid is at rest, there will be no relative motion between the adjacent or the neighboring fluid layers, which means the velocity gradient, which is going to be zero. The shear stress that is equal to mu into du by dy will also be zero. In the hydrostatics topic, we are going to study forces acting on the fluid particle due to the pressure of the fluid, which is normal to the surface, and due to the gravity or the self weight of the fluid particle. So now, in the hydrostatics, in order to understand the numerical problems better, we have few cases. When the plane surface submerged inside the liquid in the vertical direction, so the liquid, the contact liquid will be acting on the submerged bodies. The liquid which is going to exert some amount of the pressure that will be called as total pressure, which can be found using this formula. Using this formula, we can able to calculate F equals rho g ah bar, where rho is the density of the liquid, a is the area of the plane surface which is submerged. H bar is the distance of the center of a gravity of the fluid, the plane measured from the free liquid surface. Similarly, there is a one more parameter called center of pressure. The center of pressure, strictly speaking, total pressure and the center of pressure are not this pressure. Total pressure is actually the force, whereas center of pressure is actually the distance. Center of pressure is nothing but the distance by which the center of a gravity is the point of application of the total pressure from the free liquid surface. So H dash is different, H bar is different. H bar is nothing but the center of gravity, how below from the free liquid surface. Whereas H dash is the point where this force is going to act on the plane surface, at what distance that point is. That point of application of the total pressure, which is at P, that P distance is from the free liquid surface denoted as H dash. Friends, similarly, whenever the plane surface is submerged in the inside the liquid inclined, when the plane surface is inclined, in order to calculate the same two means total pressure and the center of pressure, we are going to use the same formula, F equals rho a g h bar. Whether it is a plane surface or the inclined surface, the formula to find the total pressure which remains same, that is F equals rho g h bar. Then center of pressure will have this equation. There is a slight changes in the center of pressure equation, which is going to be H dash equals Ig by H bar into sine square theta plus H bar. Friends, please listen. So Ig is nothing but that I of xx, which is nothing but an imaginary line passing through the center of gravity parallel to the free liquid surface, which is going to be Ig value. So we can use this formula. Theta is the angle between the plane of the free liquid surface and the plane of the submerged body. That angle is called theta. So now, with this background, in the hydrostatics, we have a numerical problem. Let us read the numerical problem. Calculate the total pressure on a circular plate of diameter 1.5 meter, which is immersed vertically in water in such a way that the center of the plate is 3 meters below the free surface of water. Here you have four options. So what is the total pressure? Total means the F value, capital F value. To calculate the capital F value, the formula going to be rho g h bar. So now there is a circular plate which has a diameter equals to 3 meter, that is immersed in water in such a way that its center is 3 meter below, which means H bar is 3 meter. So friends, carefully observe the formula when used F equals rho g H bar. Since it is immersed in water, rho into g product become 1000 into 9.81. Area means area of the plane surface. Since it is circular, the diameter, it has a diameter of 3 meter, then the area formula is pi d square by 4, so which becomes 1.761 meter square. So we also have H bar. H bar means the center of a gravity of this plate from the free water surface, that is equal to 3 meter. When you substitute everything, so finally you will get the answer, which is equal to 52,002.81 Newton. So here you have the answer B, which is correct. So the total pressure value will be equals to 52,002.82. And now you can see there is another problem. A tank contains water up to 8.5 meter. In the case of an hydrostatics, when there are two liquids, when there are two liquids in the vessel like this,
So the heavy liquid will be always at the bottom, the light liquid will be always at the top. When the two liquids, when they are mixed in a container like this, and there will be an immiscible layer which gets that will separate the two liquids. The lighter one will come up, and the denser one will be at the bottom. Since water relatively denser than the oil, thereby the oil is floating over the water. In this problem, it is asked to calculate the total pressure on one side of the tank. That this tank has four sides, and on all the four sides, there will be an influence of the oil and water. So you are calculating the total pressure as a combined effect of oil and water in one of the vertical side. To do this, what normally we do, we will write one pressure distribution diagram. This diagram name is called pressure distribution diagram. In this diagram, the total height, here we have water for height equals to 0.5 meter. Above the water, we also have oil, its height becomes 1 meter. Then totally 1.5 meter, it is the height of the vertical, one of the vertical plate of this tank in contact with water and the oil. So you have to write this AB line first, indicating this height. And now we have to divide. This is 1 meter. We have to divide. Actually here we have two liquids. Here we don't have any liquid about this, hence it is called free liquid surface where the pressure is zero. Here we have a oil, up to here oil for 1 meter. Then when the formula rho gh is used, we can able to calculate the pressure due to water at this level. So that is 7848. At still when you go below, and due to the water influence, the pressure will be still higher. As you go below from this point to this point, the pressure keeps on increasing. That the nature of increasing is not a uniform, because up to here it is uniform because of the liquid is oil. Up to here is uniform because liquid is water. But from year to year, that the same linearity will not be there. Thereby, you can see this is a linear. This is still linear, but these two lines are not on the same straight line. And friends, please remember, this is how we can construct the pressure distribution diagram in order to calculate total pressure. We can construct the pressure distribution diagram. This pressure here is 0. The pressure here is 7848. And similarly, we can calculate the pressure here. The pressure at the bottom of the tank, which is pressure here plus pressure due to water, that answer finally, here we have, when these two put together, 7848 plus 4905, the total sum will be the pressure here. So now in the pressure distribution diagram, so at the bottom we have the pressure equals to 7848 plus 4905. So at this level 7945. So instead of adding, just it is kept as it is because of constructing this diagram easily. So now when you draw vertical line, these two are equal to 7848. So now this is 4905. Now you have one diagram called pressure distribution diagram. In the diagram there are three components. These two are the triangle, whereas this is the rectangle. So we can calculate the F1, F2, F3. They are the forces acting on the respective pressure distribution diagram. To calculate F1, area of the triangle multiplied by width of the tank. Tank has a width which is equal to 2 meter, that is perpendicular to the slide. So when that is known, you can calculate F1, F2, and F3. So when all the three put together, that becomes the total pressure. In order to calculate the total pressure on the vertical side of a tank which consisting of two liquids, so this is the procedure. So only thing is you have to calculate carefully what is the pressure at the interface, which means between oil and water. What is the pressure at the bottom? When these two are known, we can draw the pressure distribution diagram. In the diagram, you can divide the diagram into components like this. So when there are three components, each component will be under the action of the force like F1, F2, F3. To calculate each force, the formula going to be rho G H bar. Rho, what is that H bar? H bar is the center by which the corresponding diagram, pressure distribution diagram below the free water surface. This is how we can calculate the resultant force or the total pressure. Now coming to another problem of hydrostatics, in which the plate is submerged inclined. You can see the problem. A circular plate of 3 meter diameter, which is immersed in water in such a way that its greatest and the least depth below the surface are 4 meter and 1.5 meter respectively. Determine the total pressure. So it is exactly similar to the problem of vertical case. Here in this problem, you have a circular disc which has a diameter of 3 meter. It is immersed in water in such a way that the the least depth, greatest in the least depth. Greatest means the lowermost end, The least means the uppermost end. These two are equals to 1.5 and 4 meter respectively. To calculate this, actually when the least depth and the greatest depths are given, so they don't give the theta, which we can calculate easily. Now, diameter of the plate is given, which is 3 meter, using which we can able to calculate the area of the plate. The area is found. Now, from the figure, you can observe carefully in the figure, sine theta. I have called this as a theta, which is the angle between the plate and the liquid water surface. Sine theta, which is equals to opposite by the adjacent side. Sine theta is nothing but, you observe carefully, sine theta is equal to, when this is theta, this is also theta. AC divided by BC, which is sine theta. AC means from year to year, that is called greatest depth, which is 4 meter. Then AC minus of AC by BC. BC is nothing but diameter of the plate, which is 3 meter. Then when it is AC is equal to DC, that is 4 meter. Then you can see AD, that is 1.5 meter, which is the least depth, so that we can able to calculate sine theta. So let it be as it is, as sine theta itself. No need to calculate sine theta out of it. Let it be sine theta only. FG, what is FG? It is the distance of the center of the plate. Actually, the plate, the whole plate is here. So in this view, we can, what is the shape of the plate you can see. So friends, please remember the entire plate is actually here. So this image is only showing how the plate is, whether it is circular or rectangular or whatever it is. FG is nothing but this height. This height is equal to this plus this. This is nothing but the CD, EB, this one. How the three are equal? They are equal to least depth, which is equals to 1.5. 1.5 plus this distance is equal to, when you use the simple trigonometry for this, sine theta is equal to this side by this side. When this side is known, then Bg into sine of theta will give the opposite side, that will be Bg sine theta. Bg is, that is half of the diameter, nothing but radius 1.5 meter. Sine theta is already known to you as 0.833. When that is done, you can calculate Fg. When Fg is, that is 2.7. Then finally, total pressure, Fg and the meaning of Fg is nothing but, it is the center of a gravity position from the free water surface denoted as h bar. So to calculate the total pressure, the formula going to be F equals rho g h bar. The same formula, F equals rho g h bar, where you have to be very careful when you are using rho. All the time it's not a water. You read the problem carefully, and whether the liquid is water or something else, accordingly you have to use the density. The density, since it is water, the density is 1000, G is 9.81. The area means the area of the plate. It is already, we found area using circular formula, pi d square by 4. Then finally h bar, that is 2.75. When you calculate, the answer comes 190693. 190693, you have the option second. The correct answer is the B. Similarly, fluid kinematics. Fluid kinematics, which is the branch of science which deals with the motion or the movement of the particles without considering the forces causing such motions. So there are methods of fluid motion. They are Lagrangian method, Eulerian method. Now coming to the types of the fluid. The fluids can be classified as steady and unsteady flow, laminar and turbulent flow, rotation and irrotation flow, uniform and non-uniform flow, and compressible and incompressible flow, one dimension, two dimension, and three dimensional flow are the various types of the fluid flow. Now coming to the rate of flow also called by the discharge. If you have come across the flow of liquid in the canal or in the pipe, so what is the quantity? What, with what rate the liquids are moving in the channel or in the pipes, which is called rate of flow. Rate of flow means a known volume of liquid which passes through a certain section in a given amount of time. That is called rate of flow or discharge. Its definition, it is defined as the quantity of the fluid flowing per second through a section of a pipe or a channel. If we just consider a pipe as a cross-sectional area A, and let V is the velocity of the fluid cross, then discharge becomes Q equals A, Q is A into V, where A is the cross-sectional area, V is the velocity of the pipe, then that product will give rise to that flow rate. Now, there is a popular equation in the fluid mechanics field, that equation is called continuity equation. Continuity equation, it is based on the principle called conservation of mass. You carefully look at the pipe. Actually, this figure depicts the pipe. The figure depicts the pipe. There are two sections, say 1 1 and 2 2. The pipe has cross section which is not uniform. So this is the direction of flow. The area of the pipe at 1 1 compared to area of the pipe at 2 2 will be very small. And it has a varying cross sections. From 1 1 to 2 2, pipe cross section is not a uniform. It is a very cross section. Now, in order to calculate the discharge through any section, the formula is nothing but it is the discharge formula is always rho 1 into A1 into V1. Rho 1 means density, A1 into V, which gives, that is, A means cross sectional area, V means velocity of the flow through that section. That product gives flow rate. Then the discharge, that is, it is equals to rho 1 into A1 into V1. Discharge at 2 2 equals rho 2 into A2, where rho and rho 1 and rho 2 are the densities. Since the liquid flowing through any sections in the given pipe will be same, then rho 1 rho 2 are taken as rho itself. So thereby that gets cancelled. If fluid is incompressible, rho 1 equals rho 2, then A1 and V1 will be equals to A2 into V2. That equation is called continuity equation. This equation, which is used mainly for the purpose of finding the velocity at any sections. Now coming to Bernoulli's equation, which is once again a very popular equation. Bernoulli's equation, why we use Bernoulli equation, where we use Bernoulli equation, the flowing liquid which possesses some amount of energy, the flow of liquid, it will be due to the energy. The energy will not be consistent in the pipe at every section. The energy keeps on dissipating in the flowing directions. The energy at one section will not be same at some other section. That will be same only when the fluid is considered to be an ideal. In case of the real fluids, the liquid loses energy. From time to time, it keeps on losing the energy in a flowing direction. And this is a very popular formula in order to find the unknowns. Normally, the unknowns are the loss of head. The liquid, it loses the energy. That energy is called loss of head. In the equation v square by 2 or v square by 2g, if you divide this equation in the left and right hand side by the common number, that is called g, the first term becomes v square by 2g, the second term becomes p by rho g, the last term becomes z. And that whole left hand side, and this value, actually, each term will be the energy. V square by 2g, that is called velocity head or the kinetic energy. P by rho g, that is called potential energy. Whereas Z, that is called datum head or datum energy. And when all this put together, that will be called as total head by the total energy, and which is constant. That for any given section, the energy is always constant. And now, Bernoulli's equation is derived based on the several assumptions. The fluid is considered to be an ideal. Ideal fluid is one which possesses, ideal fluid means that fluid has no viscosity. It is only for the purpose of, for certain derivations, we assume that the fluid is ideal. Ideal fluid is an imaginary fluid which do not possess any viscosity, but strictly speaking, no fluid is in existence under the name ideal, because all the fluid, they are in existence, they possess some amount of viscosity, thereby all of them are the real. Ideal fluid is an imaginary fluid. The other assumption is the flow is steady. The flow is incompressible. The flow is irrotational, are the assumptions. Now look at Bernoulli's equation, which is used or applied for the design of various flow measuring devices such as venturimeter, orifice meter, pitot tube. We use the principle, Bernoulli's equation principle, in the venturimeter designing, in the orifice meter designing, or even in the pitot meter. You observe carefully, this is actually a pipe which carries liquid under some pressure, to which, and this is called venturimeter. This is called venturimeter. and it is fitted in line with the pipe. Venturimeter has three distinct sections. They are called converging cone. That there is the middle portion is called throat, and the last portion is called diverging suction or divergent cone. So now to which a manometer called differential manometer which is fitted, and this differential manometer role is that when the manometer ends are fitted to the venturi pipe, one at here the other at here, they will always measure the differential pressure head in the form of manometric liquid like mercury. This is called manometer, which possesses some liquid called manometric liquid. Using this we can able to calculate the flow rate that I will show in the next slide. So you can see this is another device which also works on the same principle called orifice meter. Now observe carefully. In the earlier figure, we had a venturi meter which has three distinct parts like converging suction, throat is the middle portion, and there is a diverging suction. And whereas in the case of an orifice meter, so in the here you have one circular plate called orifice plate. That orifice plate has a circular, concentric circular hole at the center that is called as orifice. The water is made to flow through it. We allow the water in the pipe to flow through the central opening that is called orifice. The moment when the water is made to flow through that opening, that water gets converged. Meanwhile, the velocity will increase like anything. So, friends, please remember we use the Bernoulli's equation for the purpose of finding the flow rate using the several devices like venturi meter and the orifice meter. Now, this is a device called pitot tube. Pitot tube is nothing but a right angle bent glass tube, and it has two ends and both of them are opened. It has two ends, both of them are opened. Now, look at carefully, and these two ends are opened. Why we use this pitot tube? The pitot tube is used to know the flow rate. How we can measure the flow rate? Directly, unlike venturi meter and orifice meter, pitot tube is used to measure the flow rate. Instead, it is used to measure the velocity. So the one opening of the pitot tube is directed towards the direction of the flow. Then water in the it can be used to find the velocity of the flow either in the river or the channel. So the water will enter to the pitot tube through this opening because this is already kept in the direction of the flow. The water will rise in the tube, and it will rise like this. And we record this height using that formula rho gh. We can able to calculate the pressure in the that p equals rho gh, that formula which gives the pressure, but it is used to calculate the velocity. It is used to calculate the velocity. Directly pitot tube is used to calculate the velocity, and we use the Bernoulli's equation for this point and this point, using which we can able to calculate the velocity, and that formula is root of 2gh. And now, friends, you look at a problem using Bernoulli's equation for the device like venturi. A horizontal venturi meter with inlet diameter 20 cm and the throat diameter 10 cm is used to measure the flow of water. The pressure at the inlet is 17,658 Newton per cm square, and that at the vacuum or the vacuum pressure at the throat is 30 cm of mercury. Calculate the discharge of water through the venturi meter. Take CD value 0.98. Here you have four options. The venturi meter, the discharge through the venturi meter can be calculated using the formula CD equals A1 into A2 into root of 2GH A1 square minus A2 square. CD is given, while this A1 and A2 are the cross-sectional area of the venturi meter at the inlet and the throat. Actually, the cross-sectional area of the venturi meter at the inlet and the throat, their diameters are given at the inlet 20 cm, at the throat it is 10 cm. It is like this. Actually, this is called inlet, this is called throat. The diameter here 20, the diameter here is 10. So using these two, we can able to calculate the area A1, and using this, we can able to calculate area A2. Next, I will take you to that. So we can calculate A1 and A2 using that formula. Now, pressure at the head at the inlet. The pressure at the inlet is 70,658. That pressure head at the inlet, that is pressure heads are denoted as P by rho g in general. So the pressure at the inlet, that is nothing but P1. Pressure at the throat nothing but P2. When I say pressure head, when I say pressure head, it is always P by rho g. At inlet, P1 by rho g. At throat, it is P2 by rho g. You have to be carefully distinguish between what is pressure and what is pressure head. When I say head, that becomes the column or the height. When I say pressure, it is actually expressed in the unit called Newton per meter square. So now since pressure head at the inlet is given, thereby it is P by rho g, its value is 17,600 Newton per cm square. I kept this value in terms of Newton per meter square, which becomes 18. Similarly, pressure head at the throat. The throat pressure is given as 30 centimeter of mercury, that to vacuum pressure. Because of the vacuum pressure is always expressed negatively, whereas gauge pressures, they are always expressed positively. So for vacuum pressure, sign is minus 0.30 centimeter of mercury. So in order to calculate actually the pressure at the inlet and the throat to be in meter, and that to meter of meter of liquid flowing inside the water or inside the pipe. And since the pressure at the inlet, which is given as a meter of water, while the pressure at the throat suction, which is a meter of mercury, hence we need to convert the pressure at the throat as a meter of water, for which we have to multiply by zero point 0.3. That zero point 0.3 is nothing but it is the 30 centimeter of mercury in the manometer. So that gets converted to P2 by rho g, that too with a negative sign. Then the differentiate, as I am showing here, and H equals P1 by rho g minus of P2 by rho g. But P2 by rho g, since it is a vacuum pressure head, thereby sign itself is minus, and finally you will get H. When that H comes, actually the role of the differential manometer, it is to give the differential in the head between the two suctions in the form of the liquid which flows in the pipe. That is the main idea of having or providing differential manometer in the flow measuring devices such as venturi meter and orifice meter. So when that is used here, then Q equals CD into A1 into E2 root of 2GH under root A1 square minus A2 square. This formula gives the flow rate. So when you substitute everything, finally you will get the discharge. Normally the discharge comes in meter cube per second in SI units. So we need to convert it to LPS because the answer given in the problem is, which is in LPS. The answer is 165.55 liters per second. Now the correct answer is B. So you have to work out carefully and you have to be good at units first. Now coming to the other problem of Bernoulli's applications in the pipe. In this problem, we have a pipe through which water is flowing, which is having a diameters of 20 and 10 cm at the cross section 1 or simply 1 and 2. So this is called cross section of the pipe. This is another cross section of the pipe. It is named as 1 1 or 1. It is named as 2 2 or 2. The velocity of water at suction 1 1, through this suction, the liquid has this much velocity, and calculate the rate of the discharge, which is the rate of the discharge. Rate of the discharge, nothing but flow rate. Q you are finding. The formula is same. And friends, please see that when the pipe has tapering suction like this, you have to calculate carefully what is the area here and here. When the diameters are known, we can calculate as A1 and A2. The velocity at here is given, which is 40 meter per second. There is an equation called continuity equation, which says that A1 into V1, which is nothing but the flow rate irrespective of the cross section, the flow rate will remain same. That's what the continuity equation is. When you use A1 into V1 equals A2 into V2 in this formula, because all the values are known except V2, which can be known. Once V2 comes, then we can calculate the rate of the discharge, that is A1 into V1 or A2 into V2, that becomes 0.1256 meter cube per second. Now flow through pipes. Flow through pipes, nothing but friction and friction in pipes. There are two types of the losses in the pipe. One is called major losses, which is mainly due to friction. Minor losses, the liquid will going to lose the energy due to several reasons, such as bend in the pipe, sudden enlargement in the cross section. There are many obstructions for the pipe flow, due to which the pipe will or the liquid will lose energy. Their magnitude wise, they are very small, hence they are considered to be minor losses. But the pipe will lose maximum amount of energy, that is mainly because of the frictional losses. So this is the formula which is called as Dorsey-Weisbach equation in order to find the frictional loss. These are the various types of the losses due to sudden enlargement, due to sudden contraction, Likewise, the liquid is going to lose the energy due to any of this reason. And now, and this is called a pipe. And normally there are two types of the line, one called hydraulic gradient line, the other one called total energy line. Hydraulic gradient line, which is the sum of the pressure head and datum head of the flowing fluid with respect to the reference line. Total energy line, which is the sum of all three heads with respect to some reference line. So now this is called compound pipe. Compound pipe consisting of the various pipes having different diameters and different lengths. Now equivalent pipe. The meaning of an equivalent pipe: the pipe of uniform diameter having loss of head and the discharge equal to the loss of head, and the discharge of a compound pipe consisting of several pipes of different lengths and diameters. Uh, and friends, I thank you everyone for having participated in this program, and this is going to be helping you for coming your gate examination, and these questions are prepared with respect to the pattern of the upcoming gate 2023. With this I would like to conclude, and I wish you all the best, and hoping to meet you in our next session, in which we are going to discuss about the hydraulics. And thank you once